I think the really exciting thing about long-read sequencing is we're starting to bring in a new technology, a British technology, that can very quickly get very detailed information about a patient's cancer.
Genomics England has pioneered the use of sequencing in healthcare, and over the last 5 years it's been transformational in giving patients access to this important technology. Long reads are likely to be the next step and are likely to further transform healthcare by allowing genomic information to be accessible to all patients quickly, more cheaply, and with more information than we've ever had before.
Nanopore technology uses nanoscopic channels to read the base pair sequence of DNA strands. This technique is particularly useful for identifying DNA methylation and major structural rearrangements. So Genomics England's mission for this project is really to ensure that we get this technology embedded into the NHS. The impact we really want to have is to ensure that the technology is accessible for the clinicians. They can then utilise that to make the right treatment decisions for patients, to get the right diagnosis for patients, and also to increase the number of cancers that are eligible for this technology.
We see nanopore technology, which we are using for long reads, as complementary to the short read sequencing we routinely use.
So in our lab at Genomics England, we've started building an end-to-end pipeline which will allow us to sequence and to analyse cancers at high throughput. We have already done this for over 100 different samples comprising different cancer subtypes, and we have been able to identify all those mutations that we see in standard of care and using conventional techniques, and we can also identify large repertoires of structural variants that may have implications in both the prognosis and also the different kind of cancers that we're looking at.
Long reads are fantastic for research. It opens up what we call the hidden genome, or the dark matter of the genome, and allows us to identify changes we've seen in cancer with long reads that we would never see with older technologies. And so that will allow us to develop new treatments, new prognostic markers, and understand why some cancers progress to the way they do. So long read technology is so flexible that it should become eventually cheaper than any other type of technology, quicker, and will allow us to make genomic information as mainstream as, say, a simple blood test.
I think the biggest changes for cancer diagnosis and treatment are really trying to achieve that goal of personalised or precision medicine. That means quick and rapid testing for a patient who's just been diagnosed with ovarian cancer. It means new and more detailed ways to look at the pattern of their genomic change, and we need speed. Speed, speed, speed. You've got a lady in front of you who needs treatment. We want to be able to tell that person, this is what your sequencing readout tells us about your treatment.
The dream for us is to have this embedded in the NHS, running smoothly, accessible to clinicians, and to have ultimately a rapid diagnosis for patients with cancer.
So the future I am looking forward to with the long reads is being able to sit in a clinic on a Wednesday with the biopsy result, with those long read sequences, and being able to say to a lady in front of me, this is what it says about your faulty BRCA1 gene, this is what it says about the signatures of damage across your DNA, and these are the treatments that we're going to recommend to you. And I think that is really the promise of long read sequencing, rapid and much more detail about the changes, particularly in these hard to treat cancers.